Hello guys, welcome to another LeetCode contest video. In this video, I'm going to be trying Biweekly contest 127, so we will see how it goes. It's going to start in a few seconds, and my goal is to try to finish all questions under 30 minutes. I believe that was my personal best, so let's go. Interesting how Q4 is 7 points. Not that like I care about it too much. X is really cheap. 131. I thought the website crashed for a second. Oh yeah, of course I was gonna create a variable n, but then I actually forgot. Dang. Once one. Wish. Wait. Possible equals 0. Impossible. Player gets 1 point, clear and loses 1 point. Fails to clear. Okay. So there's 0 or 1, right? Let's start place them all given order. After each Bob will play to gain more points than Bob. If both players maximize their points. So some prefixes for Daniel. Okay, so like Dan has 1 point. Okay, so just do like isn't this just like I think it's just this prefix sum, right? Um so just per plus equal possible I if per is more points than Bob. Per's bigger than sub by plus 1. think it's just this, right? Seems like the contest is overall a little bit slow to respond, but well, yeah. Okay, so this one, 2 times 5. Oh, let me just cheese this real quick. Let me just grab. Yeah, boy. So what I need is a B. I'm not gonna do like a binary switch. Well, that's what I'm going to do. I'm just gonna say this is overkill. You can probably do like 2 pointer for this, but I'm too lazy to figure that out. So 1, 3. I probably should correct this. So I'm just gonna do. Wait, why is this 2? Okay, so wait, why? Alright, so I check I plus 1. I'm just gonna debug this. 131. I think this is correct. Let me double check. Okay. Source table. Yeah. I'm just gonna quickly debug this. Why is the second test case giving me two instead of the answer three? So I'm gonna Mhm. Okay, so one. Oh wait. Our subsequence defined the minimum absolute in two elements. Just length equal to k. So what? Oh wait. I actually forgot to do the minus point thing. I don't understand this test case. Oh, shoot. Well, that's probably important. So I'll copy this test case. Yeah, okay. So this should work now. We just run it because and make sure no behavior divergences. So I'm gonna do this in the editor. Why is the website so gosh dang slow? So into those nouns dot size. Let's sort nouns. So this implies that also that makes things easier, I guess. Yeah, probably want to count contribution. One, two, three, four. Okay, send it. Okay, so I think I know what to do. So why did I make the constraints so low? Hmm. I feel like this question's easier than I think it is. Yeah, but then I have to be careful with like including other elements and making sure the other elements don't have a smaller minimum difference. So what's the best way to handle that? Well, I guess what I would do is I will say you have to be careful with flows too. That's hmm, I guess to the power 25. One, two, three, three millimeter. That's too big. So I guess I look through all the possible differences, right? And I fix that. Well, it has to be equal to k. So brute force all the two indices have differences k. Minimum difference. So like 2k and yeah, no. What? How do I? Okay, what if I do so? If I fix like two elements such that their difference is minimum. Oh no, never mind. Or I can do that. So what would the time complex of this be? Well, it would be n times. So it would be like times 2. Fifty to the power 4. That seems. I guess I'll just sort it because why not? Nums of j minus nums of I. Should be correct. Yeah. Okay. I'm gonna fix over counting though. Okay, so now I do this. So this is guaranteed to work. If you have multiple elements such that, oh, yeah, no, this is, So if I fix that, so if I fix minimum difference, if I do that, right? Fix minimal. So many people solve it. So it's not exactly trivial. So if I fix it minimum difference, right, and I do like I don't even have to sort. So I do like dp of n and k, right, and then at times, yeah, okay. So that just so how do we kickstart this dp? Well, I guess I'll. Okay, so let me. I don't think this approach works at the end. So we do that, and then like I guess we start this dp. So we do dp of plus one. And vector of k plus 1, 0, I guess. Then we do. So say like dp of minus 1. Minus 1, 0 is equal to 1. Mhm. What's the found maximum number of different minimum differences? It's like differences possible. Well, yeah, so that's is that gonna be too slow? That's technically n to the power fifth. So n power four. I need like another DP or something. Okay, but then I guess I sort to make things easier for me at the end also. Yeah, so So instead of what's your ending index, I just retrieve some of all the DPs, right? So how would that even look like? Okay, so I guess what I'll do is this. PDP. Isn't that just DP then? I don't know. So do nums of I. No, this should be lower. Okay, so if then we do that, and this DP also include. Okay. I don't even know if this is right, but this seems pretty. It's harder than normal, but it's not impossible. Four zero six. So let me. So we have D. We have. Okay, I'm gonna have to debug this DP. 'Cause I have one, right? $16. Okay, let's not do this. Oh, shoot. Difference of four? I'm gonna have to actually print out each DP. DI K2 DP K2. Yeah. So let's take four for example. Okay, so let's start at one. So one, let's do this as well. How does that get a one? Three, four? Right. Also, if oh, I see the problem. Hmm. Oh, but this sum is rounded. This should be fine. I'm coping. Coping. I'm so coping that this works. Okay, so so if I do this, right? So I do map of that. So it's like answer plus MP of so it's second minus CNC plus M mod M mod M. Okay, so let's go. Let's go. All right, cool. Yeah, so this Q4 actually took a while. Well, GG's. Now, how many people's? Yeah, so it's like I was a little bit late, but yeah, it's not updated live. But yeah, so I will go through all the problems in the contest. So let's get to it. So the first three are pretty simple for me. The fourth one is much harder compared to all the others. So the first question, you can just try all these subarrays, and then for each subarray, you just calculate the bitwise OR. So yeah, this is what I did. So two for loops to go through all the end and start point of each subarray, and then one loop to go through the entire subarray, and then I just check the condition. I update my answer. So it's just brute force. And n is pretty sure it's 50, so you're looking at 50Q, which is fast enough. So minimum levels. So what you can do is you can try every position and see if Daniel Chain will get more points. So you can calculate the suffix sum. So if Daniel plays up to level I, right, then the rest of the suffix goes to, who is his name? Bob. So for every level he doesn't play, which is for every ones in the suffix. So this is score of Daniel Chang, and this is score of Bob. So if this condition suffices, which is just a condition up here, then we just update the answer. So yes, just compute the suffix sum and then just compute the current score for both players. This one, so I believe there is a two-pointer approach for this. So the idea, well, let me explain my solution first. So we use this thing called sparse table, which is really, really useful. Sparse table allows me to query the range, any range bitwise OR in constant time with this. So what I did was I binary search the first J such that this condition is true. And the idea is that you can binary search because bitwise OR, like the worst scenario, it just stays the same. Like the best case is that it will increase. So when we reach the minimum index, it doesn't matter if you include the other elements or not. It will always be either the same or bigger result. So I just do this. So we just want to make sure we get minimum length. So that's why first true. Update the answer. Now I think there's a two-pointer approach to this. And the idea is that like you start with the starting point being first element and then you figure out the minimum index. And you keep track of the count of bits individually. So like when you shift your starting point to the second element, you take all the bits that are on in the first element, you move their count and see if the bitwise OR is still the same. Or if it's not, then you have to extend J a little bit further. It's just the counting frequency of each bit, so you can form the bitwise OR. Literally. So that's question 3. It's more efficient than this, but it's a little bit more tedious to code conceptually without templates. Question 4 is much harder. So okay, let me think about how to explain question 4. So the idea is that let's not worry so much about this right now, because the main issue is that like if I have a subsequence, let's just say 1, 2, 3, 4, 5, right? And an idea is that you do a DP, you see how many things suffice, such that the minimum difference is at least this. So one of the ideas I tried was to try go through every single 2 elements. So I sorted, let me explain this. I sorted it first because it just makes it easier to work with. And turns out it's vital in my final solution where I have to do lower bound. So I sorted and then my idea of every possible pair of elements didn't work is because let's say I pick these two, then I can just include any subset of these 3 elements, right? But then I run through this again, which is the same difference, and I do the same thing again. So I'm over counting. So the solution I found was to go through all the unique differences since it's easier, and we just try to go for DP that says, so my DP is this, so DP of I and K2 was number of subsequences starting at I such that minimum absolute difference is greater or equal to k. With count of elements k2. So this is basically what my DP represents. So if let me extend this a little bit more. So if my k is 3, right? K is 3. Let's say I'm looking at 6. And my idea is to include a 9 because I cannot include 7 and 8 because that violates k has to be like greater or equal to 3. I'll explain why I do this later on. But yeah, so include a 9, right? What this also means I can include 6 and 10 only because the difference is greater or equal to k. And then um oh gosh, this is tricky. How did I come up with this? But yeah, so we solve this right now. We don't worry about trying to strictly make the difference being like how do I demonstrate this? Sorry, let me just think of a better way to explain what I'm doing. so this so we go through all the unique differences and we count the subsequence that has minimum absolute difference. At least this D actually. So the way we do this DP is I just start from and work back to beginning. I usually do this because m plus 1 conveniently represents like out of bounds. So like if let's say I'm at 9, right? I need k equals 3. So I need 12 for that difference. This should be D. Then it's just this index over here. So and like if I go far back to 4, right, I can include the answer for 7, 8, 9, 10. I don't have the time to go through 7, 8, 9, 10. So this DP is actually like so starting at I at least I. So this DP is kind of like the prefix sum of like the sum of the answers for 7, 8, 9, and 10. Then you can access it through 7. So we don't have to have extra for loop to go to to say, okay, so 4 plus 3 is 7. So we go add the answer for 7, 8, 9, 10. So we don't need to do that. So you can see here, so this first for loop, right, is just so a binary search where it goes and then I just, do this thing where I find like first position. So if I was a 4, add answer for 7. And notice the second for loop is I just add at the last position same count of elements with same difference. I just add it to this index. So again, it acts like a prefix sum. So dp of 0 and k is the number subsequences starting at least 0. So it can start at 0, 1, 2. Right? You can't start at -1. So that's the idea. Starting at least I, such that difference is at least D. And now for the other vital part is that if I include subsequence like 1, 5, 9, right? What my DP actually does is like it counts 5 and 9 for D equals 4, right? And but then we have like D equals 1. It also counts as 5 and 9. So D equals 4, 1, 5, 9. D equals 1. So basically what happens is the answer for D equals 1 includes D equals 4. So in order to get a true answer for 1, well, D is 1. So then I just do. Well, let me just remove this. So the idea is that the same. So this better demonstrates that you see this is 4, right? But then when we compute minimum difference of 1, this meets that criteria too. So basically D of I includes answer for DI plus 1, DI plus 2, and so on. So if we want to somehow say this answer should be 1 and answer should be 0, we have to do like D1 minus this whole thing. So that would get us the true answer. And then, yeah. So we start from the end and then we just add a count. So you can see whenever I compute the answer, which is current in this case, I start from the highest difference to the lower one. So whenever I compute answer, you can see I start with the answer for this difference. I minus the count. I minus the answers of all the previous higher differences. And then, just modular arithmetic. And then this gets us a count, but I need to multiply by the power. We want sum of the powers. So this carries a true answer for this current difference. And then I just add this answer to count. So pretty tricky problem. Took me like 50 minutes. But yeah. Let's see updated ranking. So this, yeah, it, it's a problem. It is actually a problem. GG's.